For decades, data centers have quietly powered the digital world from the ground up. Hidden in warehouses and industrial parks, they are the backbone of cloud computing, artificial intelligence, and the global internet. But today, some of the most powerful figures in technology are asking a radical question. What if the future of AI infrastructure is not on Earth at all? Jeff Bezos, Elon Musk, and other tech leaders are now exploring the idea of AI data centers in space. This is not science fiction. It is a serious strategic move that could reshape computing, energy usage, and even geopolitics. In this video, we break down why tech billionaires are racing to take AI infrastructure off-planet, what problems they are trying to solve, and what this means for the future of artificial intelligence. Artificial intelligence is advancing at an unprecedented pace. Large language models, generative video, autonomous systems, and real-time inference require enormous computational power. That power comes from data centers packed with GPUs, specialized accelerators, and massive cooling systems. The problem is scale. Modern AI data centers consume extraordinary amounts of electricity, often equivalent to small cities. They generate intense heat, strain local power grids, and require access to water for cooling. As AI adoption accelerates, governments and utilities are struggling to keep up with demand. At the same time, land availability, zoning restrictions, and environmental concerns are becoming serious bottlenecks. In many regions, building new, large-scale data centers is slow, expensive, or politically controversial. For tech leaders focused on long-term dominance in AI, these constraints represent a strategic threat. Space offers something Earth cannot: abundant solar energy, natural cooling, and freedom from terrestrial limitations. In orbit, solar panels can receive nearly constant sunlight, free from weather, night cycles, or atmospheric interference. This creates the potential for highly reliable, renewable power at a massive scale. Cooling, one of the biggest challenges for AI hardware on Earth, becomes fundamentally different in space. While space itself is not cold in the conventional sense, heat can be radiated away efficiently without relying on water-intensive cooling systems. There is also a strategic advantage. Orbital data centers would be immune to many Earth-based risks, including regional power outages, natural disasters, and certain geopolitical disruptions. For companies building global AI platforms, resilience and redundancy are critical. This is where billionaires like Jeff Bezos and Elon Musk enter the picture. Bezos's Blue Origin has been exploring orbital infrastructure concepts that extend beyond traditional satellites. Reports suggest serious interest in space-based computing platforms that could support high-performance workloads, including AI. Elon Musk's SpaceX, meanwhile, already controls the most powerful and cost-effective launch system in the world. With Starship and Starlink, SpaceX has demonstrated how rapidly deploying large-scale space infrastructure can create competitive moats that are nearly impossible to challenge. For these leaders, space-based AI data centers are not just technical experiments. They are strategic assets. Whoever controls the next generation of AI infrastructure controls the platforms, services, and economic leverage that come with it. This is not unlike the early days of cloud computing, when companies that invested aggressively in data centers gained years of advantage over competitors. Despite the promise, the challenges are immense. Launching hardware into orbit is still expensive, even with reusable rockets. Maintaining, upgrading, and repairing AI systems in space introduces complexity far beyond terrestrial operations. Latency, radiation exposure, and cybersecurity all present serious engineering hurdles. There are also ethical and regulatory questions. Who governs orbital data centers? How is data sovereignty enforced? What happens if space-based infrastructure becomes weaponized, restricted, or monopolized? These questions remain largely unanswered, and their resolution will shape how quickly this vision becomes reality. The race to build AI data centers in space signals something bigger than innovation. It reveals how critical AI infrastructure has become to global power, economics, and technological leadership. If successful, orbital AI computing could unlock unprecedented scale, reduce environmental strain on Earth, and redefine how intelligence is deployed across the planet. It could also deepen the divide between companies that control infrastructure and those that depend on it. One thing is clear: the future of AI will not be defined solely by smarter models or faster chips. It will be defined by where and how intelligence is powered. And for the world's most influential tech leaders, the next frontier is no longer just the cloud. It is space.